Unfortunately, I used the same computer as Marcus did, so there's nothing really to hook up and show. What I did was took the sign example and used it to recognize a password, but further than that, recognize who was typing the password by measuring the latency between the keys. And it basically seemed to work as long as the longer the passphrase got, the more some of the anomaly scores were harder to average out. So I started looking at your method that you talked about, and that started working, but there was some complexity in there, so that's kind of where I stopped. But anyway, yeah, it was kind of cool. Like recognize who's typing the password rather than just the password.
You should mention the fields that you used.
I used the character just as a category, and then I used the time latency. Instead of actually using an ever-incrementing time, I used the latency of time between each one of the characters. So this would be 70 milliseconds and 210 milliseconds. And then obviously if someone else typed it, those time gaps should be different. And Marcus helped me a little bit, and then he was kind of trying to type faster and see if we could catch it. But so anyway, and I might extend it and see if I could use like IP address, MAC address, time of day, maybe record how long the key is down and then how long it's up. Heavy typers, light typers, something like that.
So I thought this was interesting, just because it's kind of a fingerprint for how someone uses a keyboard, which would be an extra security measure in addition to the keys typed on a keyboard for typing in your password.
Well, that's kind of where I came at it from. My regular work has to do with finance stuff, and multi-factor authentication is a complete pain in the butt. Because you've got a password and then you've got a key fob or you've got something else, and there's always something physical to handle that. And if you could get two authentication factors in the same mechanism, that could be.
It would be really hard to fake too. So when they do the retina scan in the movies, and then the bad guy takes the guy's eye out and just puts it up to the. It'd be a lot harder to
it would
fake
mean the eye would have
someone's
to move,
typing habit.
Yeah, something like that. So, yeah. So, anyway, but it was just off a basic sign example, which was kind of cool for me because I didn't have NewPick working until Saturday morning when we started. So.
That'd be
Open source?
Well, it's the sign example. I added some stuff to record when the keys went down and went up, and recorded the data, but the model's exactly the same as the sign. I reswarmed it a little bit. I also took, when I swarmed it, the spread of bits for the scalar, for the time, it mapped out and it was able to solve it, and I think it came out with like 140 for N and maybe 20 for W. I noticed that if I bumped the N up after I'd swarmed to like, I think 600 or 700, the resolution got way better and my anomaly scores flattened out. So, like the swarmer was able to solve it at one level, but it, once we actually went into detection mode, it couldn't kind of keep up with it, I guess.
We need more swarming data.
Yeah, probably. Because I was doing it on like a 6 and 8 character password, and then I tried some longer passphrases and stuff, but yeah. Ideally, you'd want to train it on what that one person types over the space of days or weeks, so you'd know exactly that it's that person typing, but, so. Anyway.
I get the impression that swarming isn't necessarily optimized for anomaly detection. Is that true?
Yeah, the way swarming works is it optimizes the prediction error.
Mm-hmm.
And we're hoping that a model that is good at predicting will also be good at anomalies. But I think as we saw in some of the other examples, that's not always exactly true, but it's a first approximation. But what we would need to have swarming up for anomaly detection is come up with some metric that's specific to anomaly detection, and that's kind of hard.
Any other questions for Wade? All right.
Cool. Thanks.
Cool. Thank you. Sergey.
Give me a second, I have a plug in my laptop. Sorry about that. The screen went black.
The screen went black. Yeah.
Awesome.
Whoops. Okay, got it.
All right. So I think we're the last team, so I'm going to try to be really, really quick. The premise of our work is that for some reasons that people who like to be called evolutionary psychologists would be eager to explain to you people have friends. And we decided to run an anomaly detection on the friends check-ins into different places on Facebook. So we got the data from Facebook, which is a relatively difficult process considering they changed their API 4 days ago and nobody knows how it works. But basically, we go ahead. Yeah. So now it's downloading and analyzing the data to figure out which of the latest friends' check-ins are anomalous. The reason why we think that's interesting is that most of our friends kind of do the same things every day, so we don't necessarily want to talk to them about it. But if they do something interesting, something outside of their range, we'll likely to ask about it. The interesting part about this project is the encoders you.
Could you I have no idea what the data is you're actually looking
Yeah,
at.
so the data for a check-in is location of a place they checked in, with whom they checked in, how many people like the place, and categories. There's a lot of categorical data, how Facebook categorizes different types of venues.
And you can get this for all your friends?
Yeah, well,
Wow. Okay, all right, got it, thank you.
some friend, which is the default. As you can see, we tried to make the things that are very very predictable kind of transparent. So you see that people who go to bars and sandwich shops kind of transparent, but whenever it's an event that doesn't really occur all that often, it's a bit more opaque. The interesting part about this is creating the encoder, because we're not predicting any scalar value, but rather the similarity between check-ins. So you can't do any swarming, you have to manually create the encoder, and we assigned half of the SDR to location, that's half of what we consider to be anomaly, and approximately a little bit more than half of the rest to categories, and the remainders to things like how popular is the place, how frequently do people check in to it, and how many people have people checked in with.
How much data do you have? How many?
So these are the people who have the most data. On average, a little bit more than 100 check-ins per person.
For how many? What time period?
Throughout their history.
Oh,
So
throughout.
on Facebook, yeah.
So all my friends basically and all their check-ins and all his friends and all their check-ins. And then we analyze those and we surface the one that have the most data kind of, so we have the better image. Sorry.
So are you building a separate model for each friend? Is that the?
Yes.
Yes.
But you have 100 data points for each friend?
Yes.
So that's not a lot of training data.
Yeah, exactly. And so even the transparent ones, the anomaly scores are really high. They're like at 3.4, but compared to the real anomalous, which are 0.8, 0.9. So the difference is noticeable.
You're saying it actually worked?
Yeah.
Oh, okay. I wasn't sure if this you're showing what the results you're going to show us, or this is actually the results.
Yeah.
Oh.
It's the opacity
Got it.
significant, like
So-
who's
so-
cool
okay.
and who's actually boring. So you could look at it as what kind of, sorry for all my friends, but anyway.
Well, I mean, I guess you'd have to know your friends and know whether this is unusual or not.
Yes, but I mean, we based it like on if they do something different than what they do usually, then it's something interesting. But like our concepts, and furthermore, is really like, imagine you're actually going to your social media and you have all these people that saying, I'm brushing my teeth. I
Yeah.
don't want to see that.
I got it. I just don't know if Mama Bear goes to Microsoft a lot. I mean, you know, the Mama Bear conference.
That's the name of the event.
Oh, I see.
So since it's not transparent, that's unusual.
Yes.
This is transparent, so this is more.
I guess I have to trust you that that's the right score. I mean,
Yeah, you have to kind of.
yeah. Yeah.
It's the name of the event where they check.
I got it. I got it. So I wouldn't know, you know, maybe the person checking in the Fifth Street Distillery is a Mormon, never drinks at all. That would be pretty unusual, you know.
Right. We find that detecting anomaly on like contexts that are news or checks or like even is really interesting, because you could actually on the fly look at a news, for example, and know or like teach it while you're doing it, this is a content that I like, and since we have an SDR on that content, the page could be like filtered on the fly while I'm looking at New York Times, and it's actually showing me only the thing that interests me. So it's really the kind of the bigger vision. Sorry about that.
Cool. I thought it was a cool interface too.
Yeah.
Yeah, I was just thinking, while you were just saying that, it might be interesting to, if you took the text associated with the event or the place that the people had checked into,
We thought about it, we didn't
And-
have the time for it.
and combine that with the got a SEPT SDR for that,
So,
and then
yeah.
use that to further refine how the thing worked.
Yeah, there's
In Grok, we have this. We take all these server metrics and server data, and we show them in order, ranked by how anomalous they are. But this is a really cool thing. You're using this sort of opacity to sort of make it pop out at you.
Right.
Much cooler than what we did.
Did I miss anybody? Okay. That's officially the end of the event. Thanks to everybody who came out and hung out for the whole time. You guys are awesome. Thank you. I had a great time. We will be back this fall with another hackathon somewhere. Join our mailing list and join the conversation. Yeah, if anybody wants to stick around and help me like fold up chairs, pick up trash, that would be greatly appreciated.
Yeah, I think if everyone at least spends 5 or 10 minutes in
Yeah.
parallel processing would help them.
And if you want to just grab a piece of shirt or something on the way out. Yes, you can grab as many pieces of shirt as you like. For the chairs, I have some platforms for the chairs. I'll go grab.